Here, okay. On Wednesdays, we wear pink, from Mean Girls, okay? SWBA, you guys will be able to use and understand concepts of integer exponents, okay? Section 6.1. So I just passed out this note packet, chapter 6. Heads up, here's how we're going to do chapter 6. If you flip through the note packet, you might notice that there are 7 sections in here, okay? We are going to split this up into 2 chapters, okay? So we're going to do the first 3 sections. Then we're going to take a test. Then we're going to do the last 4 sections, and then we're going to take a test, okay? So we're going to split it up. We're going to chunk it into much smaller portions. That way, you guys don't have to remember 7 sections worth of material for a test. You have to remember 3, and then you have to remember 4 separately, okay? Does that make sense? Okay, the whole reasoning for that was actually to make it easier on you guys for what you had to remember, okay, and what you had to deal with on the test, okay? So that was the entire reasoning behind that. Even though it means an extra test, it means you're taking over less material, okay? So hopefully the test won't be as difficult as maybe it would be if we were to take all 7 sections, okay? Yeah, it's going to be about the normal size. Yeah, it's going to be around there, I think. So, all things. All right, so the first thing I'm going to do is write my name. So, me llamo Señor Castle, or in English, my name is Mr. Castle. Okay, so make sure you write your name. I need an L on my name. Okay, make sure you write your name on there in case you lose these or something. Okay, so we're going to talk about exponents. Okay, what are exponents?
Like that thing that are like up in the corner.
Okay, so there's a little number kind of up in the corner of another number. It's kind of above another number or variable, right? And what does it mean? Okay, Allie?
It's like, since it's like the power of, like how many times you should multiply that number by.
That's exactly right. It means to the power of something. It's how many times you multiply whatever is the base, okay? So for an exponent, we have a base. So maybe you have like 5 to the second, okay? 5, the big number, is called the base. 2, the small number, is called the exponent, okay? So that's 5 to the power of 2, 5 to the second, or 5 squared. You can say it any way you want. And what that means is you're going to multiply this number, the base, however many times together you see the exponent. So that means you have 2 5s multiplying together. So this is the same thing as 5 times 5, which is the same thing as 25. Haha, from SpongeBob, right? Okay, 25 is funnier than 24. Okay, so just a quick refresh over exponents. Very good, you guys, okay? So some important notes. If you ever see a variable or a number without an exponent, okay, like maybe you just see x, or maybe you just see 3, okay? We actually imagine that there's secretly a power of 1 there. It's really x to the first or 3 to the first. You just don't have to write that because there's only 1 3 or 1 x. And so if there's only 1 3, it just stays 3. Okay, kind of like how in front of a variable, if we don't see a number in front of a variable, like maybe the variable n, we imagine there's a 1 there, but you don't have to write it. Okay, same idea. Another thing is parentheses, okay, those little grouping symbols, are very important with exponents. When you have negative 3 squared and negative 3 being squared, the only difference between these two is the parentheses, but you actually get 2 different answers. Okay, here's what happens. The first one is essentially saying you have a negative, and then you have 2 3s being multiplied together. So you have 3 times 3. But you don't repeat the negative because the negative is not being squared. So it's negative 3 times 3. And what is negative 3 times 3?
0.
You're doing addition.
3 times negative 3.
Negative 3 times a normal 3.
Oh, that would be like negative 9.
That would be exactly negative 9. Oh, thank you very much.
Yeah.
Peanut butter. They brought me peanut butter because it's my favorite food.
I know what it is.
Oh, okay.
Ow.
Well, sorry for answering your question. Okay. The second example, okay, would be negative 3 being squared. You're squaring whatever's in the parentheses. So we're saying we have 2 of whatever's in here. So it's actually negative 3 times negative 3. But what's a negative times a negative? Positive. So it's going to be positive 9. So notice there is only one little difference in the parentheses, and that gives us a positive or a negative answer, okay? So you just have to be very careful with that, okay? And I do suggest writing that down. I see most of you are, and I really appreciate that. I think that's an excellent start to the semester, okay, is writing these down. Any questions on anything we've done so far before we get into some rules we're going to do, which are really actually shortcuts?
I just still don't understand why letters have to be in math.
I know, it's kind of a pain sometimes. It can be kind of a pain sometimes to have the letters in math. The nice thing, though, is it does open the door to be able to do more in math or apply it to more real-world scenarios. And it can even actually make it more applicable or have more of an application, even for going to the grocery store. So if we're going to the grocery store, our letters or variables can help with that. But I can vibe with you and feel that, it can be it makes it more difficult. And it's like, well, I was fine before, kind of a thing.
It's like you guys are taking 1 + 1 = 2, 7b.
There you go. So our first rule, it's like I said, these rules are really going to be shortcuts. We're going to do 3 today, okay? Our first one, product of powers. What does product mean? The answer to a multiplication problem. You guys are nailing it, okay? Answer to multiplication. Now, product of powers. We said power earlier. Allie said that was dealing with exponents, okay? So product of powers is dealing with multiplication and exponents. And if we look here, we have a to the power of m, okay? M's an exponent there. It's representing a number. A to the mth times a to the nth. So we have a product, multiplication, and powers, exponents. And it's going to equal a to the m plus nth. So what we're saying there is when we multiply these, we're going to add the exponent and keep the same base. Remember, the base is the big number. Okay, exploration. What exploration means, okay, it just means we're going to explore why this works. How did we get the shortcut? Okay, so we're going to go the long way for a second, and then we don't have to really go the long way ever again. So the long way would say, okay, let's say I have let me rewrite that, a squared times a to the 4th. So go ahead and write that down with me there. A squared times a to the 4th. So instead of saying a to the nth, we're saying a to the power of 2. Instead of saying a to the nth, we're saying a to the power of 4. So we're just putting some actual numbers attached to it, right, Allie? Mm-hmm. Oh, perfect. Thank you for already writing that down. Oh, wait, we didn't. Okay. So.
Why are you so shady today?
Oh, man, my arm's getting sore. I'm throwing too much shade. Okay. A squared means how many a's being multiplied together. That 2 tells us how many a's are being multiplied together. 2 of them. So that first part is a times a, okay? So that first part there, a squared is the same thing as a times a. A to the 4th means how many a's are being multiplied together. 4. So you have times a, times a, times a, times a. And so that second part there is our a to the 4th. And yeah, Mason, how many a's does it end up being? It ends up being 6 a's. So this really ends up being a to the power of 6. Because you end up seeing 6 a's being multiplied together, which is a to the power of 6. It's the same thing. So if we were to, quote unquote, like shortcut our way there from the original to the end, it's like we added the 2 and the 4 together to get 6. Which is what this rule is saying. It's saying that when we multiply terms, okay, we're multiplying these 2 terms, these 2 parts, with the same base as they're both a. What did we do with the exponents? We didn't multiply them. We added the exponents. Okay, so when we multiply terms with the same bases, they are both a's, we added the exponents, okay? And we'll look in a moment to see, does this work with different bases, okay? That kind of thing, okay? So let's look down here at this example. A to the 5th times a to the 7th, okay? Now remember those parentheses right next to each other? That means multiplication, doesn't it? Okay? So these are the same bases, just kind of like up here, a squared times a to the 4th. So what are we going to do with these exponents? According to our rule, according to our shortcut we just wrote down. We're going to add them, right, Graceland? So what's 5 plus 7?
What?
So what's 5 plus 7 if we're going to add them? Let's add them. 12. Oh, Cheyenne, we're going to say that? All right, thank you. Sorry. So we end up getting a to the power of 12, or a to the 12th. And that's our answer. We don't know what a is, so we don't know what a to the 12th power would be. Now, if we had an actual number in there, like 2 or 3, we could actually work that out and finish the problem, so to speak. But this is as far as we can go. We just added the exponents, okay? Once again, if you wanted to go the long way like we did up here in the red, okay, then you totally could, okay? You totally could go a times a times a times a times a, that's a to the fifth. And then do it 7 more times. And then, I have a total of 12. You can totally do that and add them that way. But this is our shortcut, okay? And so I'm probably going to stick to teaching that, okay? Does that make sense, or do we have any questions on that? Okay. So on this next problem, x squared times y, remember written right next to each other, multiplication, times, parentheses, x times y to the fourth. Okay, so we have more things going on right here. We have a couple different variables. We have x's, we have y's, we have 2, we have 4. And we don't see any exponents on a couple of them. Okay? Well, we know that these are multiplying together. Okay? Written right next to each other, parentheses, written right next to each other, all multiplication. Well, before when we've done multiplication, I'll just do an example up here in the top just so we can see it. Did it matter the order multiplied? Was 2 times 3, is that the same thing as 3 times 2? Yeah, they're both 6, right? So the order we multiply things in, it just straight up doesn't matter. Okay? So that means I can rewrite this multiplication. I can reorder that if I want. I could put all the x's together if I wanted to. That might make my life a little bit easier. If I want to do x squared times x, put these x's together, and then do y times y fourth. I'm just going to flip around the x and the y in the middle, and now I have everything in order. I have everything grouped together there, a little nicer. That might be a little bit easier for us to look at now. It's not quite the answer, okay? Okay, we do still have to simplify, okay? So, we are multiplying these x's together. So what did we do when we multiplied these a's together? We did what with the exponents? We added them, yeah. So what are we going to do with these exponents here? Add them. But what exponent is secretly on this x if we don't see it? 1. We talked about that a bit ago, right? There's secretly a 1 there. So that's x to the... that is x to the first, but x 2 plus 1 is 3. So it's x to the third. Now these y's also multiply together. And what's that become? Y to the... I heard it? I heard someone... did you say fifth, Shay? It's actually 5, okay? It's actually y to the fifth because this y also has a secret 1 there. Okay? That is a secret 1 there. We might have just missed that real quick, okay? So 1 plus 4 ends up giving us y to the fifth. Now, x to the third, y to the fifth. Are x and y the same thing? No, okay? So we can't multiply those together and call it like xy to the eighth. We can't add the exponents. We can't multiply those together any more than they are. So that's our answer. Okay? That's our answer. Okay? Questions on that or no? Okay. Why are we doing letters? Okay, so let me give some explanation to it. So a lot of this can have more real world applications, kind of like I was saying earlier. For example, like some of this can even apply to going to the grocery store. So for example, if I'm going to go through and I'm trying to figure out, how much of something I'm able to buy, or how much something would cost. Let's say, I need to go get 12 Gatorades today for this group of people I'm throwing a party for. Maybe we're just drinking Gatorade, I don't know. Or maybe I'm buying it for a soccer team. Mm-hmm. Okay, and that's a good point. Not everyone ends up using it. Okay, and so another aspect to it then is, as a school and as a nation, as the world, honestly. Okay, we don't know what every single person is going to do yet. Okay, and even if you are pretty sure there's a chance, regardless of how bound and determined you are, that it'll change. There's a chance it won't. There's a chance it will. And so because no one really knows for sure exactly what everyone's going to do, no one really knows for sure exactly what everyone needs. And so we try and give you guys kind of a broad scope and equip you for a wide variety of things. So that way, if you end up changing your mind, you end up realizing, oh, I actually want to do this. You're prepared for it. Okay? And if not, then even still, it actually gives you really good critical thinking skills and helps you process things even outside of math. It can give you great critical thinking skills even just for solving normal life problems. You're not going to drive down the highway and have to do exponents. That's not going to happen. But these can kind of give you critical thinking skills to figure out, oh, what do I need to do first? What can I do then? Those problem-solving skills. So that would really be the answer that I have to that question. I don't know if you're happy with it or not, but that's the answer I have.
You might not need it for the real world, but you need it to pass high school.
That's also a thing. I mean, yeah, that's also an answer. There's lots of answers to it. Mason.
My stepdad, his stepdad was a bricklayer,
Yeah?
and he didn't know what he was going to do, but he finished high school, but he didn't go to college, but he can do fractions in his head, and he decided to be a bricklayer, and he's been doing it for like 20 years.
Yeah, and so he probably does a lot of fractions as a bricklayer right now, right? Yeah, and so you're like, so to your point, if I'm understanding you correctly, correct me if I'm wrong, but if I'm understanding you, you're saying he didn't know what he wanted to do. He didn't know he would need fractions and needed to know to do them quickly. But now that he does know how to do them quickly, it helps him a lot when he ended up doing. Yeah, so it ended up working out very well when he ended up figuring out what he wanted to do or changed his mind or however he got there. Yeah, thanks for sharing that. All right, any other questions before we move on to number 3 here? All right, number 3, this one looks big and scary, right? Okay, we got a few different things going on. How many sets of parentheses do we have here? 3 sets of parentheses. Yep, 3 open and closes, okay? So in this last one, I know you guys don't see 1/2. It kind of looks like a blob on yours, doesn't it?
Yeah.
Okay, go ahead and write in 1/2 real quick, okay? Go ahead and write in 1/2 there. I just printed wrong. Sorry about that.
Why are you so... Wait. I have a problem.
What's your problem?
You see where that black dot is? That's you.
No, I have a different sheet. Or something. Because
You can see it.
Oh, I've been doing it on the wrong
Oh,
one.
you're on the wrong one. I'm sorry.
Girl, oh no. Well, at least you've been writing it down.
Ruh-roh raggy. Oh, that's true.
At least yeah.
Intense.
All right, and pencil. Okay, so what we're going to do here, guys, okay, is just like when we had
100%.
problems like this off to the far right side, okay, just for room, okay? Let's say we had 5 times 2 times 3. What did we do when we had a scenario like that?
Okay, explain that.
Not
Or is it?
multiply how many of them together to start? We did 2 of them together. We would just do like the first 2, like 5 times 2, call that 10, and then do 10 times 3, right? And call that 30. So you just kind of ignored the last one for a second, and then you kind of brought it back. Okay? We're going to do the same idea. Right? Are you able to wait a bit to do that? I think it just might help you better focus if you don't. So we're going to kind of ignore that last one exists. Don't cross it out, okay? I'm just crossing it out up here so you guys can better visually see it, but I can erase it really easily.
So we write it.
Okay? So, we're going to focus on these first 2 for now. So we have 9y squared times negative 2x squared y to the third. On the previous example, we ended up grouping our x's and y's together. But after we practice this a bit, you can actually cut that middle step out. Okay? You can actually cut that middle step right here out. You can go straight from here to here and say, oh, x squared, x to the first, 2 plus 1, x to the third. Oh, okay. Y to the first, y to the fourth, 1 plus 4, y to the fifth. Okay, we're done. So you can cut out that middle step if you want. If you want to still have it, you can. What we're going to do is we're going to multiply each similar thing together. So we're going to multiply the 9 and the negative 2 together. What's 9 times negative 2? Negative 18 is correct. Okay. Now we're going to look at x's. Let's go alphabetically. Okay. X comes before y. Okay. Are there any x's in this parenthesis?
Yeah.
In the first one?
No.
No. Okay. Are there any x's in the second parenthesis? Okay. And it's x to the second. So we're just going to keep our x to the second there. There's no other x to the second to change it, so we're just going to keep x to the second. Now there's a y squared and a y to the third. And those are multiplying. Okay, we can see there with the parentheses next to each other and all the variables written next to each other, that means multiplication. So what are we going to do with those exponents on the y's, the 2 and the 3, since we're multiplying the y's? When we multiply the same base, we blank the exponents. Multiply terms of the same base as we what? We add the exponents. So what's 2 plus 3? 5. So this becomes y to the 5th. So it's just kind of like we did this number 2, but over here with some different numbers, variables. So those first two parentheses become negative 18 x squared y to the 5th. Any questions on how we got to this step? So I want to make sure we're all kind of on the same page here before I move on.
I'm ready.
I can't tell if it's like 2 different lines or all one line.
What do you mean 2 different lines? No, yeah, what do you mean by 2 different lines?
Like, are the x and the y under the number?
Oh, okay. So the negative 18 is supposed to be like a big number, okay? Let me write it bigger so I can maybe explain it better, okay? So I'm just going to put the same thing over here.
No, I can see it. I just couldn't tell like if the x and the y are under the 18.
Oh, okay. Gotcha. Okay. So the bottom of the x and where the y should be, that should be like written on the same. Let me put it in black here. Maybe that'll help to clarify, because I get what you're asking. If it was like that, okay, to pretend this little curved line was what I was writing on. Does that help clarify? Yeah, that's a very fair question. Thanks for asking that. Okay, I don't want you just to be confused the whole time, so I'm glad you did. Okay. So now we're going to bring back in that one we kind of crossed out for a moment, okay? So we need that first part multiplied with this 1/2 xy to the 5th. So now we're going to do this multiplication. So just like before, we're going to multiply those numbers together, the coefficients, the big numbers together. Negative 18 times 1/2. Negative 18 times 1/2, okay? And if you ever want to do these off to the side, you totally can. As a matter of fact, let's do it off to the side right now, okay? So negative 18 times 1/2. Well, it can often help us to put that negative 18 over something. What would we put it over? 1. Everything numbers secretly over 1. Now we can do this thing called cross-reducing. Do you guys remember cross-reducing?
Yeah.
Okay, is there something that goes into both the negative 18 and the 2?
Oh yeah, 1 goes into 1, and then it's actually 9. But
Okay. It becomes 9 because what goes into it? What goes into both 18 and 2? 2 goes into both. 2 goes into 18 9 times, and it's still a negative. And 2 goes into itself once. Now we multiply straight across. Negative 9 times 1 is negative 9. And on the bottom, 1 times 1 is 1.
I said it. Negative 9. That's what I said.
Yeah. But do we really need that over 1?
No.
Nah. So we can call this first part negative 9. Now, guys, another way you can do this with the fractions, multiplying by 1/2. Well, guys, what's half of negative 18?
Negative 9.
Negative 9. That's how we got that. So it's like you just divided it by 2. Okay? Very good, very good. Now, x squared and x to the first. What would those end up becoming when we multiply them? When you multiply the x's, what do we do with the exponents? Add them. So x squared, x to the first. What do we end up getting? X to the... Justice, what did you get?
I don't know yet.
Okay. So we have x squared, and we have x to the first. We have a 2 and a 1. And what did we say we're going to do with those exponents? Add them. So what's 2 plus 1? 3. So we end up getting x to the third.
Sorry, was that a justice question?
It was, but you're good. Okay. Yes. Hopefully not your lightning as well. Okay. Yes. Okay. So now we need to do the y's as well. So we have y to the 5th and y to the 5th. Well, we can add those exponents again because we're multiplying. Allie, what's y to the 5th times y to the 5th? What are we going to do with those exponents we said?
Like
Add them. So it becomes y to the...
first.
Not quite. I think you divide it, okay? So y to the 5th and y to the 5th. So it's 5 plus 5? 10. So it becomes y to the 10th. And at this point, we don't have anything that's the same anymore to multiply. Negative 9 doesn't have anything else to multiply with. X doesn't have anything else to multiply with. And y doesn't have anything to multiply with. So that's our answer, okay? Before, in the previous steps, we always had more to multiply with. Now, we don't. Questions on that at all? Okay. Yes.
I got sloth socks for Christmas, and I thought of your wife.
Oh, man. That's awesome.
I was gonna wear them today, but I was like, I'll just wear them.
That's great. That's great. I gave my wife some socks as an early Christmas present. And she did. They had one pair had narwhals on them, one pair had llamas on them, and she loves llamas. And one pair has sloths, of course. So
A lot of people don't believe in animals too.
it's kind of crazy, isn't it?
My mom did not know until like 2 weeks ago. It's not an animal.
I mean, they seem like they should be imaginary.
How are giraffes real, but unicorns aren't?
I mean, all right. We're gonna start on rule number 2 here, okay? Yeah.
Created a horse and a narwhal together.
I don't know if that's biologically possible. Otherwise, someone would probably have tried it.
We learned about this in biology.
So, power of a power. Okay, power means exponents again. So it's like exponent of an exponent. It's an exponent raised to another exponent. Oh my gosh, what mind blown, okay? A to the power of m to the power of n. What it says we end up doing is we multiply those exponents together, m times n. Okay, once again, we're going to do some exploration with this. So we're going to have a to the second being raised to the 4th. A to the second being raised to the 4th. Okay?
In parentheses.
And it is in parentheses. Very good, very good, okay? And we're actually going to pause here, and we're going to continue on after lunch on this portion, okay? So we're going to pause here, and we're going to continue on after lunch on this portion here. We said that the 2 really means there's 2 A's being multiplied together. So the 4 would mean there's 4 of whatever's inside the parentheses being multiplied together. So in this case, it's the same thing as there being 4A squareds multiplying together. So we can go ahead and write that down. That's the same thing as there being 4A squareds being multiplied together. That's what that exponent of 4 would mean.
Do we have to write that if we already know what it means?
I encourage it just in case you go back and look at it. Yeah, what's up?
You're a really good teacher. I know, like I said, it's like every time. I do. I really
Well, thank you. It means a lot every time.
Every time.
Yeah.
Do you play Minecraft?
I played Minecraft 3 times in my life.
Okay, I'm just kidding.
Okay. But there's no swearing on my Christian Minecraft server. Memes, okay? So now, this is something very similar to what we had on the previous examples. We turn this into something very similar to what we've had. A squared times A squared times A squared times A squared. They're all multiplying and they're all A's. So what did we say we could do with the exponents a moment ago before lunch? We can add them up, okay? Mason's showing me the symbol for addition, okay? We can add those exponents up. So what's 2 plus 2 plus 2 plus 2? 8. Very good. So this becomes a to the 8th, okay? So a to the 8th, if we shortcut the way there, okay, if we kind of shortcut our way there using our rule,
Oh, you can just multiply.
you can multiply the 2 and the 4 to get 8.
In the blank, right?
Exactly. So when we raise a power to a power, we multiply the exponents. I love the enthusiasm. I love that. That makes me happy.
You're welcome.
So we're going to multiply these exponents, okay? Hey, Rye, I'm going to ask that we go back to our seat now, okay?
I have 2 more.
Okay.
I'll put them on my phone.
I'll give you a second, but then you get these notes when you get back to, okay?
Mm-hmm.
Okay. So let's practice with some other expressions. A to the 3rd raised to the 5th. So what would we do with these 2 exponents? Multiply them. So what's 3 times 5? 15. And so it's a to the 15th. Very good, very good. Some teamwork making the dream work. I love it. All right. I want you guys to try number 2 on your own. Okay, when you have it or have questions, raise your hand. Amazing things that I walked through, okay? We multiply these exponents because it's x to the 4th raised to the power of 3. So 4 times 3 is 12. So we get x to the 12th. Questions on that at all? Alrighty, so on this next one, we have 2 squared to the power of 3. What was that? Okay, that's okay. So what would we do with these exponents? Multiply them, so this becomes 2 to the 6. Now, on this one, can we actually do 2 to the 6?
Yes.
We totally can, so we're going to, okay? We couldn't have done that with x, we couldn't have done that with a, because we don't know what they stand for. But we know what 2 is. So that means how many 2's are multiplying together? 6 of them. So there's a couple different ways we can do this, and I'm going to show you both of them, okay? And
Can we do the example thing where you write on the board for like 3 people, get them to write on the board for like 3 different ways? Why are you talking? Shut up, Mason. Didn't you like say that that was like a thing that we do?
That was in Springer, I think.
But I like the
Springer.
Springer's way. I don't.
I don't know what you're referencing.
Can we just like
She wants you to
me
work
put
out
those on the
each.
board. She wants us to write the answers on the board. Like,
You know what? Never mind. It's taking too much time. Go.
Like give us a problem to solve and we'll write it on the board when we get it right.
Oh.
Not like that. Like
No,
different
like
ways.
each individual problem, you pick 3 people to do it on the board.
Oh, okay, gotcha. And see if you guys do it the same or different ways.
I don't know.
Gotcha.
Exactly.
Okay. Okay. Well, we'll start off with this though. Okay. So 2 to the 6th. Either way, it's going to be 6 2's multiplying together. Okay. So one way you can do it is say, okay, what's 2 times 2? 4. What's 2 times 2? 4. What's 2 times 2? 4. So now you have 4 times 4 times 4. Okay, what's 4 times 4? 16. And we have another 4. So 16 times 4 is the last thing we need to do, is 64. And that's our answer. That is 2 to the 6th power. Another way you could do it, two times 2 is 4. Bring down another 2. 4 times 2 is 8. Bring down another 2. 8 times 2 is 16. Bring down another 2. 16 times 2? 16 times 2. Right, you want to put that away? Not quite 24. 30 something.
36.
32. We're close, we're close. And then now 32 times the last 2 is 64 again. So did we get the same answer either way? Yeah, so realistically, it doesn't matter which one you choose.
It looks like a heart.
I want you to, like a pan flute. I want you guys to choose whichever one is easiest for you. And if you have your own method, cool. That's great. Okay. I'm not going to say this has to be done this way or this way. Okay. I'm giving a couple of different options here. Okay. So if Graceland says, for example, and I don't know which one you prefer, if any. If Graceland says, I really like the one on the left, she can do the one on the left. Okay. If Shay says, I really like the one on the right, and once again, Shay, I don't know which one you prefer, if any, then she can do the one on the right, though. She says, hey, I like that one. Okay. And then if one time you're like, no, I want to try the other one, I'll try the other one. That's cool. Okay. Any questions on these at all? All right, Mason.
No homo, Shay. You're really pretty. No homo. I got it. Well.
Continuing on. Power of a product. So once again, power, exponent, product, multiplication, okay? So this time we're taking a product, we're taking multiplication, A times B, they're multiplying, raising that to a power, to the nth. And what we notice is they end up actually both being raised to the power of M, okay? So let's do another exploration. Okay? For this exploration, we're going to do AB squared in parentheses. And then outside the parentheses, we're going to raise that to the third power. Oh, cool. So AB squared, and we're going to raise that to the third power. So what this is saying is inside the parentheses, we have A times B squared, and we're raising this product to the power, hence power of a product. Now, just like on the last one, we're going to rewrite the inside, but we're going to rewrite the inside how many times this time? how many times do we have AB squared being multiplied? 3, because that's the exponent on it. So we're going to say that's AB squared times AB squared times AB squared. We're just going to have 3 of whatever's inside the parentheses multiplying together. Yep. Now, since these are multiplying together, we can take the ones with the same bases, the A's or the B's, and add the exponents. So what's the exponent on this A? I heard it? 1. What's the exponent on this A? 1. What's the exponent on this A? 1. So what's 1 plus 1 plus 1? 3. So this becomes A to the third. A to the power of 3. A cubed, however you want to say that. What do the B's become? B to the... Not quite. Okay. I heard it. 6. How'd you get 6? 2 plus 2 plus 2. So just like we did 1 plus 1 plus 1 to get 3, we'll add these since we're multiplying all the bases together. We add the exponents. 2 plus 2 plus 2. That's 6. So we end up getting A to the third, B to the 6. So this time our shortcut that ends up happening is we ended up having this 3 become A to the third. So it was like an A to the first originally. So 3 times 1 is 3. What's 3 times 2? 6. That's how you get the 6. Is that similar to distributing? Do you guys remember distributing? Okay. Distributing earlier was like if you had this and you take the 4 times the x and get 4x and the 4 times the 2 and get 8. Okay. It's kind of a similar idea where this time we took A to the first, B to the second, and said, okay, 3 times 1, A to the third. 3 times 2, B to the sixth. And that was our answer. So when we raise a product to a power, we distribute the exponent. We distribute the exponent. Okay, so we're going to practice doing this. So we have a couple examples. We aren't going to do all 6 of these examples today. Okay, just so you know, we are not going to do all 6 of these. Okay, I wouldn't cross them out, but we aren't going to do them all today. So x squared y, all being raised to the power of 4. That looks kind of similar to what our example does, in my opinion. So what are we going to do with this 4 that's outside the parentheses, that exponent that's outside the parentheses?
Oh, what we just did.
Multiply.
Yeah. Multiply with 2 as well as something else, actually. So we're going to multiply with 2 and the 1 that's secretly on the y. Very good, Cheyenne. Heck yeah. So this ends up becoming x to the what?
2 times 1 is 2, and so if you take 2 times 4, then it's 8.
That's 8. So x to the 8th.
It says distribute.
Never mind. I'm sorry.
I think you're thinking of something earlier, maybe.
You mixed it up, Mason. It's okay, Calvin.
And then it becomes y to the what?
Well, nothing.
4. Yeah, y to the 4th. 1 times 4 is 4. So this is x to the 8th, y to the 4th. And now we have x's and y's, so we can't do anything more with that.
Can we do number 3?
Like right now?
Yeah.
Sure, we can do number 3 and then go back to number 2.
There's a lot of...
Yeah. Would you rather do that before or after number 2? Okay, cool. Let's try it. Yeah, let's try number 3. Okay. So we have kind of a lot going on, right? Okay. So once again, this might be a good thing to where it's handy for us to kind of just like mentally cover one side of it up. We'll cover up one parenthesis. Maybe even put your hand over it or a piece of paper over it, something like that. Even just as a mental reminder. Not going to focus on that right now. 3g to the third, h to the fourth, and this is all being raised to the power of 2. So once again, we have a 2 outside the parenthesis, just like we have the 4 outside the parenthesis.
Would the 3 have a 1?
The 3 does secretly have an exponent of 1. Very good, Olivia. I was gonna see if anyone noticed that. Okay? Yeah, Cheyenne.
So we take 1 times 3, right?
Not quite. What did you say? At the end there?
I said 2.
You said 2. We're going to take the 1 times the 2. So it becomes 3 to the second. What else do we do to that exponent of 2 outside the parentheses? Multiply it to the 1. And we multiply it to the other exponents, the 3, g to the 6, and to the 4, h to the 8th. So we have 3 squared, g to the 6, h to the 8th. Now, a very common thing I see, super common I see, okay, is a lot of people like to say 2 times 3, that's 6. But is 3 squared going to be 6? No, 3 squared is 9. So a lot of times I see people just say, oh, 2 times 3, 6. Be careful, exponent multiplies with the exponent. Exponent doesn't multiply with regular number. Exponent with exponent only. Okay? So now let's go ahead and do the other one that we kind of blocked off for a moment there. So what are we going to do with that 4 that's outside the parenthesis? Distribute it, yeah. So whenever we see an exponent outside the parenthesis, this is what we're going to do. We're going to multiply it to every single exponent. Now, what exponent is secretly on the 2 right now? A 1. So we're going to do 4 times 1 and get 2 to the 4th. Very good. G is secretly to the power of 1. So 1 times 4, g to the power of 4, a 4th. And what's h going to be to the power of? It's originally the power of 5. 20. H to the power of 20. Pretty big.
H is the strongest letter out there.
It's just built different. All right, now before we can actually still multiply these together, because now this kind of turns into like one of the original problems we had today, one of the ones we had before lunch. We actually still need to do 3 squared. Because we said 3 squared was something earlier, didn't we? Yeah, we said it was 9. So let's call that 9. And then g to the power of 6, h to the power of 8, stay the same. And then 2 to the power of 4. Okay, if we need to do that off to the side, definitely can. 2 times 2 times 2 times 2. What's 2 times 2? 4. It is 16. And we still have g to the power of 4, h to the power of 20.
Can you like do something and combine g to the power of 6 and g to the power of 4? Isn't there something that in the h's too?
You're darn right, okay? So now we're going to look to multiply these together, and Cheyenne's right on the right track here. We're going to end up having to do the g to the 6. We're going to do something with that and the g to the 4, something with the h's, and we're also going to do something with the 9 and the 16. What operation's happening between these two parentheses? Multiplication. When they're right next to each other, it's going to be multiplication. So we have to first do 9 times 16. How many of us know 9 times 16 off the top of our head? Okay, probably none of us. Okay, so is there any shame in writing that down? No. Yeah, let's write that down. Okay, so let's go with, I'll put it up here. 16 times 9, 9 times 16, it doesn't matter which order you do it in. What's 9 times 6? 54. So I'll put a 5 above the 1, drop a 4. What's 9 times 1? 9. And then add 5 to that because we have that 5 still. 14. So it ends up being 144. So you get 144 for the number. Now what are we going to do with those g's? G to the 6th times g to the 4th. What happens with those exponents? They do add. Very good, right? So it becomes g to the what? 24. Not quite. You multiplied them. 10. Very good, Shay. And it becomes h to the power of what? 28. 8 plus 20? 28. And that, is now our answer. That got pretty big, didn't it? Now that got pretty big. Okay.
I'm not gonna lie, that's really confusing.
Okay. Was there any part in particular, like the first line or the second line or the third line or just too many in general? Okay. So did you feel like any one individual step was overwhelming or just kind of the whole collection? Okay, just kind of like the whole collection, right? Doing them all. Okay, so that's one nice thing to it is no individual step is like the hardest thing we've ever done. Okay, I mean you can make simple mistakes, that happens. Okay, but it's just remembering. Okay, now I can do this. Okay, now I can do this, and that's where that problem solving, critical thinking I was talking about earlier comes into play. Of saying, oh, I see this. What do I do when I see that? What do I see when I do that? Oh, I do this when I see that. Okay, same idea. Okay, so when we see the exponent outside the parenthesis, okay, we're going to multiply to all the exponents. Okay, well, let's look at what you have now. Well, I have an exponent on a number. Okay, I can do that. 3 squared, okay, that's 9. Same thing over here. Okay, that's 16. Okay, well, now what do I have? I see a lot of multiplication. Okay, well, now we add stuff and now we multiply. Okay, and so that's kind of a way to walk through. I know we're not going to all just get it like that right now. Okay, that's why we're practicing. Okay, is so that way we start to kind of see these patterns more. Because at first, it probably is going to be confusing. It probably is. And we're going to practice it and try and work through it and get a little more comfortable with it over time. Now that we did the big one, number 3, let's actually backtrack and try number 2 here. Okay. So what are we going to do with this?
Don't forget there's a 1 minus 2.
Whew, I love that. That is music to my ears. Don't forget, there's secretly a 1. That's an exponent for the 2. Okay? So we see an exponent outside the parentheses. Have we seen that before?
Yes.
Okay, and what do we do when we see the exponent outside the parentheses? Multiply. Multiply the exponents. Distribute that exponent. Okay? So we're going to do 3 times what? Not times 2, but times the 1, the exponent. So what's 1 times 3? 3. So it becomes 2 to the power of 3. Then what else do I do with this 3? Distribute to the other exponents. So what's 3 times 3? The next exponent. 9. So it becomes p to the power of 9. And what's q to the power of now?
What?
Q would become to the power of 6 because 2 times 3. Justice, does this look completely done to you? Okay, what are you seeing? Okay, it's not simplified. What can still be simplified? Okay, do you want to phone a friend? Okay, Cheyenne's ready to help.
The 2 with the 3.
Yeah, do we know what 2 to the third is?
No.
Or we can at least find it, right? Okay, 2 to the third, that's how many 2's multiplying together? 3 of them.
So it's 8.
2 times 2 times 2, that is 8. So this is 8 p to the power of 9 q to the power of 6.
To me, the P, the 9, the Q, and the 6 all look alike.
They are they're just kind of like rotations of each other, isn't it? I hope no one in here is dyslexic because that might be an issue.
I think I am. I'm not being serious
Yeah.
about it too.
That can make those especially could be confusing then.
Me
Yeah.
and one of my little brothers have issues with letters and numbers.
Yeah. Any questions on number 2? Okay, we're going to do... Yeah, we'll do 4, 5, and 6 next class. Okay, we'll stop here for today.
Okay.
Okay?
That's good. I'm proud of that.
Just put a line.
But for next class, do 1 through 12. Yeah, you can put a little line there, like after 12. Okay? Maybe write a little note to yourself. Just do numbers 1 through 12 for next class, okay? And now some of these are really hard to read on the homework, I'll be honest. Okay? Probably the one that's the hardest to read, in my opinion, is number 9, okay? So everyone, if you can take your attention to number 9 real quick. Number 9 should be e to the power of 3, f to the power of 2. The second parenthesis is e to the power of 2, f to the power of 4. Okay? So those exponents on the f's, those are really hard to read. Okay? So the first f has an exponent of 2. The second f has an exponent of 4. Okay? Any question on that?
Can I listen to music?
You definitely can listen to music, okay?